All right, so this is a somewhat brief Helix NS3 filters tutorial. What we're going to go through first is just understanding a bit about Helix filters. Some of this might be reviewed from previous tutorials, but I'm going to make the assumption that users know how to build and run Helix federates as well as the broker. I won't cover that in too much detail. I'll go over a brief understanding of NS3, and then we'll learn how the two work together. So a refresher on Helix message federates. The idea is that you register endpoints with a string name, and if you do it without using register global endpoint, you end up with internally it's registered as federate name with a / and then the endpoint name that you specified to the register function. Sometimes with some simple, maybe 1 or 2 federates, it might be easier to use global endpoints, which just registers an endpoint name exactly as you specified. And then you're able to send messages using the message federate to the endpoint, using the endpoint that you registered previously, and then given a string name of the endpoint you're trying to send the message to. Then using filters, we have the option to register source filters. In fact, I'm using the special high-level function to make source or make destination filters, and that API will show up on a later slide. But there is some boilerplate federate setup using the federate info class, specifying the name of your federate, and possibly loading some things from a JSON file or command line. So I've got line numbers. This is source code. This would not compile if you copy and pasted it. But it specifies at least some of the basics behind creating a Helix message federate. So in line 1, you specify the name to the federate info constructor. In this case, I am specifying a time delta of 1 second for this federate info. And then the message federate is created on line 3. I'm registering an endpoint on line 4, just called source, and this is using the register endpoint function, so it's not global, meaning this is actually going to be my name / source as the endpoint. And then I also have a destination endpoint on line 5. We go through initialization on line 6 and 7 of the federation. And then I have a very simple for loop, and that's supposed to represent stepping through 10 seconds of time. And at each time step, I'm sending just a basic string message. So that's set up on lines 9 through 10, and then sent on line 11. And so you see I'm using the source endpoint ID and sending to itself. So this is actually a standalone application that's just sending a message effectively to itself, just another endpoint represented within this federate. So then it requests a new time every time through the loop, checks for messages, and that's it. So this is a basic message federate. Now if you want to now add filters, someone's sending a message on Skype. All right, so this is adding a fixed time delay of 2.5 seconds. The code is primarily unchanged, but if you look at the highlighted section, this is the only part that changed from the previous slide. So we're registering a source filter, and we're calling it filter 1 on the source endpoint. And what we're doing is we're creating a message time operator on line 7, which is taking a lambda function in C++ and just adding 2.5 to the original time of the message. And so then anything leaving source, so that's the endpoint registered as source on line 4, anything that's being sent using that endpoint ID will go through this filter. And so it'll add 2.5 seconds to the delivery time of the message. So we can do random time delays instead of fixed time delays, so this is a little bit more flexible. It might represent better what NS3 could be doing for you if you were using it. So you can do random delays, and so I'm doing make source filter, and so we see that I'm creating a random delay filter type on the source endpoint again, and I'm using the exponential distribution with a parameter of 1. Otherwise, again, the non-highlighted portion of this message federate stayed the same. We also have the option of randomly dropping messages. So this will represent like a congested network where it can't handle too many messages and it might drop them. So you have the option, random drop, random delay. These things can be emulated fully in NS3 also, but if you want to kind of ease into the fact that you might not receive all your messages or receive them later than possible, this is an option as well. So there's a lot of different random delay distributions available in Helix. These are all basically wrapping the random distributions that come as part of the C++11 standard. So there's a link there if you want to see them. And then the names are on the left in quotes. And then the make source filter that we saw previously, the types of filters that are currently defined, delay, random drop, reroute. Rerouting filter is what's being used in the NS3 implementation, but I wanted to highlight that this is the list of currently supported filter types. All right, so I've hardly talked about NS3 so far, and that was on purpose because you really shouldn't use NS3 until you've fully tested your federates, your message federates, using the built-in filters. Meaning, if you don't know, if your federate does not know how to handle a message arriving at a time other than what you were expecting, if you're expecting perfect communication that's instantaneous in your application, adding NS3 would just add too many wrinkles to what you're trying to do. So first, understand how your federate works on its own. Then use the built-in filters. And then when you're ready, use NS3. But don't just jump into NS3. You need to have a fully tested NS3 network model ready. Then you can incrementally add Helix to that. That's my recommendation. So this is a bit of a repeat from the previous tutorial. Yes, we have NS3 integrated with Helix in a separate repository. It is forked from approximately NS3 version 3.2.7. And if you clone that repository, it'll automatically put you into the Helix branch as default. And that has our Helix contributions under the contrib directory. And at this time, NS3 is still not available on Windows, and you can follow the NS3 email list to find out what's going on there. Just a recap how to build NS3. Hopefully you can, when these slides are available, you can just look at this and pretty much copy what's being done here and see what the output looks like as an example of a successful WAF configure invocation. So I'm not going to tell you exactly how to do NS3 if you've never used it before. They do have a great tutorial available. There's a link to it. The key abstractions is just a graph. Everything's a node and a graph, and then you install on these nodes your network devices. So these are like your network interface cards. But primarily, the actual logic of what happens are the applications. And so there is a Helix application that we've integrated, but you don't have to know all this, low-level detail. We're trying to make this easy on users, so we've created a Helix Helper class that takes care of a lot of the guts that you don't want to know about as far as the Helix integration. Just understand that if you have an NS3 network model ready to go, then you can install Helix on any of the nodes, and I'll get into that on the next slide. So the Helix Helper class, there's just a handful of functions, and those are the only ones you need to use. In fact, setup federate will register a message federate with Helix using the name NS3, and that's why I did it as a separate function. So it just calls setup federate, and it uses 1 nanosecond as your time delta. Then the only other function you'll need to use is the install filter function, and you specify an NS3 node and then the name of that node, and that name corresponds to the endpoints you registered in your, the previous slides, the basic message federate. So there was a quote source and a quote dest filter or endpoint names. So you install filters on these names. And so, like I said, if you have thousands of nodes in your well-vetted NS3 model, you can just pick a couple of them to install filters on and give them some names from your corresponding message federate endpoints. So the example code is on the bottom of the slide. When you call install filter, it returns you an application container. And then you need to specify when to start and stop. This is an NS3ism. So the individual applications installed on nodes have to be given when to start running and when to stop running. And we could probably make this a bit more elegant for users, perhaps doing this all at once, starting all of the Helix applications at the same time and stopping them at the same time. But this is where we're at today. So when you install a filter, when you give it a name, it's really just creating a message dest operator and registering it with Helix. And so then any message sent to the name you've specified, and again, this is back in your basic message federate, a few slides ago. It's just sending from source to dest, meaning any message sent from source endpoint is just going to have its destination rewritten. And in this case, it's rewritten to NS3 as a prefix to the name that was specified. This is all happening transparently. The whole point is that message federate that you have that's been well tested, standalone, sending from point A to point B, as long as that works, it's going to work with NS3 because you're just overlaying for your well-vetted NS3 model the same names you used as part of your endpoints that you registered in your message federate. So if you get into the examples I've provided as part of the NS3 Git repository, so if you look in the contrib directory under Helix examples, you will find a fed filter, which is just your basic message federate sending from source to dest. And you'll also find the NS3 model using the network topology you see here. And it's just installing a filter on node 0 and node 4. It's really simple, but it illustrates that you can go from a very simple message federate, perhaps with filters that you've tested, and then you can remove those filters, go back to the basic message federate, and then add NS3 as a network model, and then install just on nodes in your model with the same endpoint names. So really this is the tip of the iceberg. I mean, you can have very complicated NS3 network models, maybe using Wi-Fi, add traffic generators, packet tracing. Again, I want to emphasize create your networks first and test them independent of Helix. Create your message federates, standalone, well-tested, using delay filters or drop filters first, and then glue it all together. So that's the end of this brief tutorial. Any questions?
This is Trevor Hardy at PNNL.
Yeah.
You mentioned that the built-in Helix filter types allow for message delays and drops. Do you support out-of-order delivery of the packets?
So if you had a random delay and you were sending two messages, from say from source to dest, if that random delay, yeah, you could end up with out-of-order messages. And that would certainly happen, assuming that the randomization of the times caused that to happen.
Excellent. Well, thank you, Jeff.
Yep.